All right, welcome back to the deep dive. Today we're diving into something pretty fundamental, really. Something that sort of underpins almost every intellectual pursuit we undertake.
Yeah.
Information. We treat it like a commodity. We guard it fiercely. We seek it out constantly. But have you ever really stopped to think about what it actually is
hmm
at its core?
Hmm. It's an interesting question, isn't it? We often talk about information in terms of signal versus noise, like distinguishing a pattern from just pure randomness.
Right, that idea that if the universe was completely unpredictable, completely random, it wouldn't actually convey anything to us. It would just be noise.
Exactly. So, in a sense, information arises from deviation, from the unexpected, something that breaks the pattern, stands out from the background noise. It carries weight precisely because it's not what we'd expect in a purely random system.
I see. So it's all about probabilities. Speaking of which, that kind of leads us nicely into the specific type of information we're going to be looking at today. And I just want to make it clear from the outset that we're not talking about bits and bytes transmission signals.
Mm.
That's Shannon's territory, and it's fascinating in its own right.
Oh, absolutely.
But today we're venturing into the realm of semantic conceptions of information, meaning we're interested in the actual meaning being conveyed, the content of the message itself. When you hear a sentence, what knowledge or supposed knowledge does it actually give you?
Yeah, so we're shifting focus from the carrier of the message to the message itself. We want to understand the intentionality behind it, the representational capacity of the language being used, and that's a really crucial distinction, especially from a philosophical perspective.
Absolutely. And to help us navigate this fairly complex terrain, we're going to start by looking at a pretty early attempt to formalize this whole concept of semantic information, a theory developed by Barhill and Carnap. I'm sure you're familiar with their work.
Yeah. Oh, of course. It's a foundational theory, although, as we'll see, it does run into some problems along the way. But their attempt to apply the rigor of formal logic to this slippery concept of meaning was certainly influential, very influential.
Okay, so let's start with the basics. What were Barhill and Carnap actually trying to achieve with this theory? What was the driving force behind it?
Their goal, I think it's fair to say, was incredibly ambitious. They wanted to develop a way to precisely quantify the semantic information contained within any given sentence. And to do this, they deliberately chose to work within the framework of monadic predicate logic.
Monadic predicate logic, which for our listeners who might not be familiar is a kind of simplified logical system, right? So why would they restrict themselves like that?
Right. Well, you have to remember that natural language, the way we speak in everyday life, is incredibly messy and complex, full of ambiguities, contextual dependencies. It's a nightmare to try and formalize. So by focusing on monadic predicate logic, they created a much more controlled environment, a system with clear-cut objects and properties that could be analyzed in a more rigorous way.
Right, so it's about creating a sort of controlled laboratory setting for their theory. Makes sense.
Exactly. And at the heart of their theory was this idea called the inverse range principle. Basically, it states that the amount of information something conveys is inversely proportional to some other measurable property.
Okay, so the more informative something is, the less of this other property it has, and vice versa. What exactly was that other property in their model?
The probability of a sentence being true. And this probability wasn't based on any actual observations or data, but rather on an a priori probability distribution across all logically possible states of affairs, all possible worlds, if you will.
Okay, so before we even encounter any actual evidence, we have this built-in sense of how likely any given statement is. Sounds like a pretty rationalist approach.
It is. It's all about logical analysis, you see. Looking at the structure of the language being used, the possible ways objects can have properties, and so on. And the more probable a sentence is, the less semantic information it's considered to carry. And conversely, the less probable it is, the more informative it becomes.
Interesting. So in a way, they were trying to build a system that considers all these possibilities beforehand to figure out how much a sentence actually narrows them down, how much it tells us about the world.
That's a great way to put it. And to really get into the nuts and bolts of this, they started by defining something called the content of a sentence. This is denoted as a cont, and it represents basically the set of all possible worlds where that sentence is false. It's important to remember here that possible worlds aren't really about alternative universes or anything like that. It's more about, like you said, different ways things could have been, different states of affairs.
I see. So the content is all about what the sentence rules out, what
Yeah.
it tells us can't be the case.
Exactly. And then you have the flip side of that, which is the intention of a sentence. And that's simply the set of all possible worlds where the sentence is true. So together, the content and the intention cover all the bases. They're mutually exclusive and jointly exhaustive, meaning every possible world falls into one or the other.
Got it. So if a sentence has a larger content, meaning it's true in fewer possible scenarios, it feels like it should be more informative, right? Because it's eliminating more possibilities.
Exactly. That's the core intuition they were trying to capture with this whole framework. And to make it more precise, to actually put numbers to it, they introduced two key measures. The first is the content measure, which is written as cont. It's calculated as 1 minus the a priori probability of the sentence, which is denoted as PS.
Okay, so that's how they quantify the content.
Go.
And the second measure.
The second measure is the information measure, written as INFS. And this one is a bit more complex. It involves taking the base 2 logarithm of 1 divided by 1 minus the content measure.
Hold on, logarithms? Now, I have to ask, why introduce two separate measures? It seems like it'd be simpler to just stick with one.
Well, it all comes down to some pretty technical mathematical reasons. Basically, they needed two measures to properly account for how the information content of different sentences interacts when you combine them. The content measure, is additive when you're dealing with sentences that are content independent. This means they don't share any possible worlds where they're both true.
So their contents don't overlap at all.
Exactly. And in these cases, the content of the conjunction of those sentences, meaning the content of both sentences being true together, is simply the sum of their individual contents. But the information measure in FEF behaves a bit differently. It shows additivity when you're dealing with inductive independence, where the probability of one sentence doesn't influence the probability of the other.
So inf makes more sense when the information in each sentence is coming from a separate, independent source, so to speak.
Precisely. And, this actually reflects something we see in the real world, right? The way we combine different pieces of evidence to form our beliefs.
That's a really interesting point. So, okay, they had these mathematical tools, these measures, to try and quantify semantic information. But as you alluded to earlier, there were some pretty significant challenges when they tried to actually put this theory into practice.
Oh, absolutely. One of the biggest initial hurdles was this question of how to actually define and enumerate these possible worlds. It sounds simple enough in theory, but it quickly becomes very complex when you consider the expressive power of language. Even if you only focus on a very small fragment of natural language, the number of possible worlds just explodes.
Yeah, I can imagine. So how do they deal with that?
Well, they made a strategic decision to further limit their scope. They restricted themselves to working with monadic predicate logic with only a finite number of predicates. Let's say, for the sake of argument, that you have n predicates. This means you end up with 2 to the power of n possible objects and a staggering 2 to the power of n possible worlds. They called these state descriptions. And even with this simplification, the system was still incredibly complex. As you mentioned earlier, Hintika later tried to extend this to full predicate logic, which is even more expressive, but the problems of complexity remained.
Right, so they were working within a very, very controlled environment. But even then, their theory ran into some serious philosophical problems, didn't it? I'm talking about the famous paradoxes that emerged from their work.
Yes, exactly. And these paradoxes really threw a wrench into the works. Two of the most prominent ones are known as the Bar-Hillel and Carnap semantic paradox, or BCP for short, and the scandal of deduction, or SOD. Let's start with the BCP. It arises from the fact that their framework ends up assigning the maximum possible amount of information to contradictory sentences.
Wait, maximum information for a contradiction? So a statement that can never be true, something like A is B and A is not B, is considered to be the most informative thing you can say. That doesn't seem right at all.
It doesn't, does it? But it's a direct consequence of their definitions. Think about it. A contradiction, by its very nature, is false in every possible world. So its content, remember, is the set of all possible worlds where it's false. And since it's false everywhere, its content encompasses literally all possible worlds. Maximal content as you can get.
Ah, I see. And if you plug that into their formulas, you end up with a content measure of 1 and an information measure that approaches infinity. So it's like their system is saying that the most informative thing you can say is something that's completely meaningless.
Exactly. And this really highlights a fundamental problem with their approach. By focusing purely on the logical structure of sentences, by detaching information from truth, they end up with results that just don't align with our intuitive sense of what information is supposed to be.
Right. It feels like they're missing something crucial here. So how did they try to address this paradox? Did they have any response to this?
They did, but it was a bit of a head-scratcher. They argued that their notion of semantic information was what we call non-factive, meaning truth is not a requirement for something to be informative in their system. They claim that even a false sentence could carry a lot of information, in this very technical sense of the word. In fact, they famously said that a contradiction asserts too much, it's too informative to be true.
Too informative to be true. It's a catchy phrase, I'll give them that, but it still feels like they're dodging the real issue here. I mean, come on. The idea that utter nonsense is the most informative thing you could say is just absurd.
I agree, it's hard to swallow. And this really highlights two key weaknesses in their response. First, the fact that their definition of information is non-factive just rubs up against the way we normally think about information. We tend to associate it with truth, with some kind of connection to reality.
Right. It's hard to imagine something being informative if it has absolutely no bearing on reality.
Exactly. And the second weakness is that, well, their claim that this non-factive measure actually captures our intuitive notion of informativeness is very debatable, to say the least. I mean, do we really think a contradiction is more informative than, say, a true statement about the world?
Doesn't seem very convincing, does it? Okay, so that's the paradox of contradictions.
Yeah.
But then they also ran into problems at the other end of the spectrum, right, with the so-called scandal of deduction. What was that all about?
So the SOD highlights the issue that logical truths, also known as tautologies, things that are necessarily true by definition, were assigned zero information in their system. Think about a statement like, either P or not P, it's always going to be true no matter what P is.
Yeah, it's like logically unassailable. But surely there's some information contained in that, right? It feels strange to say it has zero information.
Right, and this is especially weird when you consider that logical deductions, while they preserve truth, often reveal new connections between things. They expand our understanding in a way that feels, well, informative. That's exactly the point. And to be fair, Bar Hillel and Carnap weren't completely oblivious to this. They admitted that there might be other senses of information where logical truths do carry information. Perhaps a more psychological sense, where the information lies in the process of understanding or deriving the truth.
So they're suggesting that the informativeness of a tautology isn't in its content itself, but rather in the mental effort it takes to grasp it, to see its implications.
Yeah, that's the implication. And they also made reference to Claude Shannon's concept of informational pluralism, which basically suggests that different contexts might require different definitions and measures of information. Both Shannon and Bar Hillel and Carnap seem to agree that a single one-size-fits-all theory of information might not be possible, or at least not adequate.
Informational pluralism. It sounds like they're admitting that their framework might not be able to capture everything we intuitively associate with the word information.
In a way, yes, and it seems their attempt, while groundbreaking in its rigor and ambition, ultimately stumbled on these fundamental philosophical issues concerning truth and informativeness.
Yeah, it's a fascinating case study. It shows just how difficult it is to try to pin down something as conceptually slippery as information. But thankfully, their work didn't end the conversation. It actually spurred a lot of further research into semantic information.
Oh, absolutely. And one of the most influential responses to their work, especially the paradox of contradictions, came from Luciano Floridi and his theory of strongly semantic information. Fleury basically argued that the core problem with Bar-Hill and Carnap's approach was this very separation of information from truth, this non-factive nature of their framework.
So Floridi wanted to create a much tighter link between information and truth, to ground information in reality.
Exactly. His central argument was that to qualify as information in the strong sense, it has to be true. It must be factive. And this immediately solves the BCP because a contradiction, by definition, is always false. So it simply doesn't count as information at all, according to Fleury.
So he just sidesteps the whole issue of contradictions being too informative by saying they're not informative at all. Simple and elegant.
Very much so. And the article you shared also mentioned other approaches that try to address these issues, which they call alethic approaches. These focus on truth-related concepts like truth-likeness or verisimilitude. Thinkers like Fricke, Cevallani, and Delfonso have explored this avenue.
And in those theories, the informational value of a statement depends on how close it is to being true, even if it's not completely accurate.
Precisely. So a statement can be almost true and still have some degree of informativeness, but it wouldn't qualify as strongly semantic information in Floridi's sense because it's not entirely true.
Got it. So for Floridi, truth is like a gatekeeper. It's a necessary condition for something to be considered strongly semantic information. And how does he go about actually quantifying this kind of information? if it's not based on probability, like in Barhill and Carnap's model?
Well, Flaherty shifts the focus to the idea of distance. He uses the Greek letter theta, to represent the distance between a true proposition, let's call it P, and the actual situation in the world, denoted by Z. And this situation is like a partial representation of the world, a snapshot, if you will.
Okay, so it's like, how accurately does the proposition P reflect the actual situation Z? And the closer the match, the more information it conveys.
Exactly. So perfect accuracy means the distance is zero, maximal closeness. And that would represent the highest amount of strongly semantic information because it perfectly captures the truth of the situation.
That makes sense. And what about contradictions and tautologies? How does his framework handle those?
Well, here's where it gets interesting. For Flaherty, a tautology, something like either P or not P, represents maximal distance in the direction of truth. It's true in every possible situation. And he argues that this actually corresponds to minimal informativeness because it doesn't tell us anything specific about the actual situation.
Right, it's kind of like saying something is either true or false, which is true by definition, but doesn't actually give us any new information about the world.
Precisely. And this actually echoes Wittgenstein's famous view that logical truths are essentially empty, they say nothing.
Yeah. And what about contradictions?
Now, this is where it differs significantly from Barhill and Carnap. A contradiction, for Flaherty, represents maximal distance in the direction of falsity. But instead of being maximally informative, as in the previous theory, it actually results in a complete absence of strongly semantic information. This is because it violates the fundamental factivity condition. Remember, for something to be strongly semantic information, it has to be true.
Oh, so he neatly sidesteps both paradoxes. Contradictions aren't information at all, and tautologies have minimal information. Very clever. But there's still this lingering question. If strongly semantic information must be true, how does he account for the fact that sometimes false statements can be very informative? You know, like in his catering example, where knowing the slightly wrong number of guests was more useful than knowing a broad range.
That's a great point, and it's something Flaherty directly addresses in his work. He makes a clear distinction between strongly semantic information and what he calls informativeness. He acknowledges that false statements can be informative in the everyday sense. They can provide specific details that help us narrow down possibilities, even if those details turn out to be wrong.
So it's like they have practical value, even if they don't meet his strict definition of information.
Right. To capture this, he introduces a separate measure for the degree of informativeness, denoted by the Greek letter iota. And it's calculated as 1 minus the square of the distance from the target situation, z. This measure ranges from 0 to 1, where 1 represents the highest degree of informativeness.
So a true statement that gives a very precise, accurate picture of reality would have a high degree of informativeness, while a true statement that's very general, that encompasses a lot of possibilities, would have a lower degree of informativeness.
Exactly. And even though that very general statement might not be as informative in this sense, it still qualifies as strongly semantic information because, crucially, it's true.
It's a subtle but important distinction. So Flaherty is really putting truth front and center. It's the foundation of his whole system.
Absolutely. And he's not just stopping there. As the article pointed out, he extends his theory into epistemology, arguing that knowledge itself is essentially a coherent, organized body of strongly semantic information. And he goes on to explore related concepts like epistemic relevance, and even proposes a correctness theory of truth that's specifically tailored for semantic information.
So he's built a whole philosophical system around this idea of factive semantic information. But this veridicality thesis, the idea that information must be true, it's not without its critics, is it?
No, it's definitely a point of contention in the philosophy of information. Some philosophers, like Dinan and Bronner, argue that this requirement of truth is too restrictive, that it might prevent us from developing a truly unified and comprehensive theory of information.
They're saying that maybe there are types of information that are valuable even if they're not strictly true.
That's their argument. But then you have others, like Mingers and Standing, who strongly defend the veridicality thesis. They see truth as essential to the very concept of information. And then there are those who advocate for what we talked about earlier, informational pluralism, like Allo. They suggest that maybe different concepts of information are valid depending on the context. And some, like Vakarelov, are trying to approach the whole issue from a more naturalistic perspective, grounding semantic information in the physical processes of the world.
So the debate is still very much alive. And it's been fascinating to trace this evolution of thought, from the early mathematically focused work of Bar-Hillel and Carnap to Floridy's truth-centric response and all the other perspectives in between. It really shows how difficult it is to fully capture the essence of information, to pin it down with a single definition.
It does, doesn't it? The contrast between Bar-Hillel and Carnap's probability-based, non-factive approach and Floridy's factive, distance-based approach highlights this fundamental tension in our understanding of information. How do we reconcile the logical, mathematical aspects with our everyday intuitions about truth, meaning, and relevance? These paradoxes we discussed really bring this tension to the forefront.
And it's been so interesting to see the different strategies philosophers have used to grapple with these deep questions. Some try to resolve the paradoxes within the existing framework, while others propose completely new principles.
Exactly. And while we focused on these foundational theories today, the field has continued to develop in fascinating ways. As we mentioned, there's been a significant move towards more naturalistic accounts of information and meaning, exploring how these concepts might arise from causal interactions in the world, the flow of information through channels. But that, as they say, is a deep dive for another time.
It is. It is. We could talk for hours about this. But for now, I think it's worth leaving our listeners with a thought-provoking question. Considering all these different philosophical perspectives on semantic information, what does it actually mean for us to say that we understand something? How does the information we have actually relate to the truth of the matter? And are there cases where something that's false can still contribute to our knowledge, to our understanding of the world? It's a complex issue with no easy answers, and I think it's something worth pondering. Thanks for joining us on this deep dive into the philosophical world of semantic information. Until next time.